In this video, we're going to talk about Consul. Consul is a tool from HashiCorp that provides a solution in three main areas. This includes service discovery with real-time health checking, service mesh with Consul Connect, and network infrastructure automation. In this video, we will briefly go through the architecture of Consul and the problems that it solves with service discovery. In future videos, I will cover the service mesh and network automation pieces. Although this video is specifically on Consul, these service discovery concepts can be applied generally. Let's get into the architecture. At its bare bones, a Consul cluster is made up of agents running as either a client or a server. This agent is responsible for tasks such as membership information, registering services, and running health checks. In this diagram, I have three servers labeled A, B, and C, and they are running the Consul agent in server mode. Servers take on additional responsibility of being part of the consensus quorum, leveraging Raft to work together to determine a leader, while the other two will be flagged as followers. Underneath the Consul servers, we have our Consul clients. These clients are responsible for running the application as well as the Consul agent in client mode. A client can watch for the services that come online, register that service, and begin performing health checks. Clients are responsible for forwarding RPCs to Consul servers to update the centralized registry. All nodes in a Consul cluster communicate over the Gossip protocol using Serve. At a high level, Gossip provides membership, failure detection, and broadcasting of events to the rest of the cluster by random node-to-node communications. The last piece I want to talk about is the concept of a Consul data center, which is what we have defined here. Consul defines a data center to be a private networking environment with low latency and high bandwidth. Within the same data center, nodes are also known to talk over the LAN gossip. In the event you wanted to bridge two Consul data centers together, your servers would take on the additional responsibility of communicating to Consul servers in another data center over WAN gossip. Let's now talk about service discovery. When introducing this topic, I like to use a two-tier app example and show an environment that does not leverage service discovery, followed by one that does. On the far left, we see a monolithic app defined. These monolithic apps were apps that had many moving parts all coupled into one big application. As we begin or continue our journey to a microservices approach, we can see on the right that our application is now decoupled. Let's assume our app B here is an API server and app A wants to consume it. Easy enough, app A will need to know the network location or IP address of app B, and then that location can be hard-coded into app A. Although this will work, let's assume our API becomes increasingly popular and we need to scale it horizontally with more compute as shown in the diagram. Now, in order for app A to take advantage of the scaled-out API, we either need to hard-code two more IP addresses into app A or stick a load balancer in front of app B and let app A know of the new load balancer IP. Again, this will work, but we've now just shifted the problem to the load balancer. We've introduced a new single point of failure in that if the load balancer goes down, our app can no longer consume our highly available API. On top of this, the load balancer still needs to be manually managed. As we move into more dynamic environments, the instances that these applications live on can be dynamically changing due to autoscaling, failure, or upgrades. In this case here, manually updating network locations could be done, but as the application grows, we can see that having to manually track and update networking locations, it is not a scalable solution. Taking what we've learned about Consul's architecture along with what we discussed in the example, we can now look at the same environment but with Consul and the concept of service discovery. At its bare bones, service discovery is typically a combination of a centralized service registry and health checking. Consul specifically creates and maintains its own registry that contains a list of registered applications as well as their networking location. Additionally, Consul can also be configured to monitor these apps, and in the event it becomes unhealthy, Consul will recognize that and ensure it is no longer discoverable. This becomes very beneficial in a microservices architecture like Kubernetes, where networking addresses can change frequently. In our example specifically, we can now remove the need for the earlier defined load balancer and have our applications query the Consul registry when it needs to look up the location of a service. This solves two big issues. One, we can have developers focus on writing quality code for their apps and not worry about writing in-app health checking and let Consul handle that. Secondly, With this approach, we can be assured Consul will only return healthy online instances, so we can no longer have to worry about manually updating DNS records or load balancer configurations. With that, we have quickly gone over what Consul and service discovery is in 5 minutes. I hope you found this video useful and are looking forward to the follow-up video where I discuss Consul's service mesh feature with Connect. If you are interested in learning more about Consul, we have linked a couple talks and blogs in the description below. Thanks for watching.